Hello everyone, welcome to 13.1. In chapter 13 we're going to talk about expressions and equations, and more specifically in section 1 we're going to talk about algebraic expressions. Our learning target today is I can explain how to simplify expressions. Okay, expressions, equations, what's the difference here and how do I simplify them? That's what we're going to learn about today. For our key idea today, it says parts of an algebraic expression are called terms. So another way that I like to think of an algebraic expression is a math sentence. And sometimes math sentences have numbers and letters. Right? Now that we're dealing with algebra, we're talking about some things that might be unknown. A lot of times those are variables represented by letters. And parts of our math sentences are called terms. So kind of like an English sentence has like nouns and pronouns and adjectives and all those different pieces to an English sentence, math sentences are broken down into terms. And more specifically, like terms are terms that have the same variables raised to the same exponents. So for example, x and x would be, or x and 3x, or y and 2y. Those are like, they have the same variables raised to the same exponents. Notice there are no exponents. Here's another example, z to the third power and 2z to the third power. Both have z to the third power. Those are like. Okay. Then it says constant terms are also like terms. Remember, constants are just numbers all alone. Okay, they're constant. They don't change. They're always that number. So for example, 5 and 3 are constants. We know that we can add 5 and 3. They are like. To identify terms and like terms in an expression, first write the expression as a sum of its terms. First write the expression as a sum. So, in other words, change all your subtractions to additions and the next to their opposite. That's that. This is that chop rule that we've talked about, where we take our subtraction, change it to addition, and the next term to its opposite. So for example here, it wants us to identify the terms and like terms in each expression. First, I'm going to write it as a sum of its terms. So I'm going to rewrite this as 9x, and I'm going to change this to addition, and the next to its opposite. So the opposite of 2 is negative 2, plus 7, plus negative x. I'm going to do the chop method there. Okay, and then I'm going to break this down into its terms. So you can separate an expression at the addition signs. So here's an addition sign, here's an addition sign, here's an addition sign. You'll see that we have 1, 2, 3, 4 different terms. So our terms are different parts to this expression. The first term is 9x. The next term is negative 2, then 7, and then negative x. Okay? Then, lastly, so there's my terms. I need to also identify my like terms. And remember, like terms are terms that have the same variables raised to the same exponents, and constants are also like. So my first set of like terms, I see I have 2 terms that have x's with them. So my first set would be 9x and negative x. Those are like. And I also have, so I'm going to put a comma, negative 2 and 7. Those are like because those are constants. Okay? Let's look at letter B. Let's do the same for letter B. Let's first write the expression as a sum. So I'm going to rewrite this as z squared plus 5z. I'm going to change this subtraction to addition, so plus, and then next to its opposite. So negative 3z squared plus z. Okay, so my first step, I just changed this subtraction to addition and the next to its opposite. Then I'm going to separate my expression at the addition signs, and I'll see once again that I have 1, 2, 3, 4 different terms here. Yeah. So my terms are z squared is my first term, comma, 5z is my next term, negative 3z squared is my third term, and lastly I have z. And then I need to identify my like terms. So which of these have the same variable raised to the same exponent? Well, first I see that these two z's are both squared, so those are like. So I have z squared and negative 3z squared are like terms. And then I also have 5z and z are like, because they both just have the z and there is no exponent there. There are no constants, and so now I am finished. Okay, for my vocab here, it says an algebraic expression is in simplest form when it has no like terms and no parentheses. To combine like terms that have variables, use the distributive property to add or subtract the coefficients. Okay, so let's take a look and see what they mean by that with example 2. It has lots of different variables and numbers here, as you can see. First, I see that I've got a few subtractions right here, so I'm going to rewrite this as an addition problem, same as I did before. So I'm going to rewrite this as 3/4 y plus 12. I'm going to change this to plus and then negative 1/2 y. It just allows us to see what's positive and what's negative a little bit clearer. And I'm going to also change this subtraction to addition, and I'm going to change the 6 to its opposite. Okay, so now when I simplify these, I'm going to look for my like terms. I'm going to look to combine my like terms. Okay, so let's look and see what is like. Well, I have 3/4 y and I have negative 1/2 y. So can I take and add those two things? Well, they both have the same variable y, and all I would need to do is to add their coefficients. The coefficient is the number in front of the variable, right? So all I need to do is I need to take 3/4 and I need to add, I'm adding negative 1/2. Negative 1/2 is the same thing as negative 2/4. I'm going to change that right away so that when I add fractions, I have a common denominator. Okay, 3 plus negative 2 is 1, and then 4/4, I'll keep my common denominator. So 3/4 y plus negative 1/2 y would give me 1/4 y. So I've added those two like terms together. And I also have one more set of like terms. I have this 12 being added to this negative 6. So what is 12 plus negative 6? 12 plus negative 6 is 6. That's a positive 6. So I end up with 1/4 y plus 6. And I've combined my like terms, and now I'm in simplest form. Here is your answer. 1/4 y plus 6. All right, why don't you pause the video now, take some time. There are 6 on your owns here that will be really good practice. Don't just write down the answers. Please, please, please try them out on your own first. Okay, for number 1, 2, and 3, I'm going to write my terms and below it my like terms. So my terms for number 1, you should get y, you should get 10, and you should get -3 halves y. Like terms, we've got our 2 terms with y. So we got y and -3 halves y. Notice the 10 doesn't have anything like it, so we just don't put anything. Okay, our terms for number 2, we have 2r squared, we have 7r, we have -r squared, and we have -9. And for our like terms, we have 2r squared and -r squared, and that's it. Notice this one has an r, this one does not, so these two are not like the 7r and this -9. This -9 is a constant, and that's not like this. Lastly, for number 3, your terms, you should have 7, you should have 4p, you should have -5, you should have p, and 2q. There are 5 terms here, 1, 2, 3, 4, 5. And then for our like terms, you should have 7 and -5. Those are both constants. Those are like. And also 4p and p are like. They both have the variable p. Number 4 through 6 here, you have to simplify. So we need to combine our like terms. So -3z plus z would be -2z. And then we have 14 plus 8, which is 22. So -2z plus 22. Number 5, add our x terms together. They are like. So that would be 6.8x minus 5. You don't notice how we don't do anything with this. We can't combine it with anything, so we just write it along with it. Number 6, these are both like, so you can combine them. You can take 3/8 b and subtract 3/4 b. This would be the same as 6/8. So 3/8 minus 6/8, you should get -3/8 b for an answer. Okay. Let me know if you have questions on any of those. For example 3 here, we've got a situation where you are going to need to use the distributive property to simplify this. Remember, whenever you see this number outside of the parentheses, it means to distribute it inside the parentheses or multiply by everything inside the parentheses. So -half times 6n, in other words, what's half of 6? Well, that would be 3n. And then what's a negative times a positive? That's a negative. And then we have -half times 4. Well, -half times 4 is -2, so we could say plus -2. And then we don't distribute a half to this because this isn't in the parentheses, so we just bring it down in our problem, plus 2n. And now I look to see, do I have any like terms that I can combine? And as a matter of fact, I do. -3n plus 2n would give me -1n, which is the same as -n. I didn't do anything with my plus -2, so I'll just bring it down in the problem. Remember, that's the same, adding a negative is the same as subtracting. So I could also write that as -n minus 2. That would be the same as that. Okay. Why don't you go ahead and pause the video now to try 3 of those on your own. All right, for number 3, you should arrive at 3q minus 1. Excuse me, number 7. Number 8, you should arrive at 5g minus 8. And number 9, you should get -3x plus 8. Please let me know if you have questions on any of those, and I'll be glad to go over them with you. Lastly, we have the real life application. It says each person in a group buys a ticket, a medium drink, and a large popcorn. Write an expression in simplest form that represents the amount of money the group spend at the movies, and interpret the expression. Okay, so what I'm going to think of is the different things that everybody is going to spend. Each ticket, everybody needs a ticket, right? Everybody's getting a drink, and everybody's getting a large popcorn. And when we add those three things together, we should come up with how much money the group spends at the movies. Okay, so do we know how many people are going? We know how many people are going? No, we don't, so let's call that X. Okay, so each person is going to get a ticket. Well, a ticket is $7.50, and it's $7.50 per person. So that's why it's times X. Plus, they also need, each person gets a medium drink, which is $2.75. So $2.75 per person, so times X. Plus a large popcorn, which is $4 per person, so 4 times X. All right, here is an expression that will give us our total. Well, these are all like, notice they all have an X, so I can combine them all. What's 750 plus 275 plus 4? That would give you $14.25 per person, $14.25X. Okay? And that represents, when it says interpret, that means what's it mean in the problem? That means that each person will pay $14.25. Okay? There you have it. That wraps up section 1 here with algebraic expressions. Please let me know if I can help you anymore. But some of the big takeaways are knowing what like terms are and being able to simplify expressions using those like terms. Thanks for checking this video out. I will see you guys next time.